Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at an AriserTalent. AriserTalent is an e-learning platform where you can get the video lectures recorded by the expert faculty of the Kota team, where you get the entire content along with the sample paper, test series, so time to time you can analyze your performance, and we are also provided with the doubt section where you can post your doubt to us, and the faculty will answer you within the 24 hours. So what you have to do, you have to get the notifications of the video and more amazing videos like this. You have to subscribe our channel at www.arisertalent.com. so just press the bell icon and subscribe our channel. So I'm your physics teacher Krina, welcomes you all, and we have started our first chapter, that is about the light, reflection and refraction. So what we have dealt in our previous lecture, we have seen that what actually the refraction is. So let's do a quick revision of that thing again. Refraction is actually a bending of light rays when it is traveling from one medium to another. It means when light is traveling from rarer to denser or denser to rarer, it is going to deviate from its path. So this phenomena is actually known as the refraction we have seen, and we have discussed about the three cases regarding refraction. Now in today's lecture we are going to discuss about the very interesting phenomena that is related to refraction from our day-to-day life and what are the laws of refraction we have. So let's start with the chapter. So today we are going to deal with effects of refraction. So firstly, we will deal with effects of refraction, and secondly, we are going to cover laws of refraction in this chapter. Firstly, we are dealing with effects of refraction, and secondly, we are going to deal about the laws of refraction. So these two important topics we are going to cover in our today's lecture. Now, first topic is effect of refraction. So we have to discuss here what are the effects of refraction you can see in your environment. So first example we have is that when you dip a pencil in a water, you can see that the pencil appears shorter as compared to its actual length. Secondly, we always see when we see in a deep water tank, the water appears shallow. It means it is assumed to have a low height as compared to its actual height. There is an apparent shift in the position of sun during sunrise and sunset. This is also due to the refraction of light. And the very interesting phenomena that is known as twinkling of stars, this is also occurring due to the refraction of light. So let's discuss these important phenomena here. So in effects of refraction, the first thing we are going to deal about is So this is how the pencil appears when placed in water. You can see that this is the actual length of the pencil we have, but when you immerse this pencil in water, the rays after refraction reaching through the observer of an eye, the pencil seems to be appear here. So you can see that when this is placed in water, it is observed that it appears of the shorter length to the observer. So this phenomena you have observed in your daily life, and this is actually related to your refraction. So this is the first case we have. Second case is water appears to have a less depth when seen from the upper part. You have generally observed that when you see from the topmost part of the water tank, the water appears at a very less depth, but it is actually at a greater depth. So this is again a concept that is related to refraction. So what happens in this case? This is our water tank. So this is how the water is filled up to this level and the observer see water up to this depth. It means to the observer this depth appears to be shallow in case of water tank. So similarly, just like a pencil, this is the another case we have that is belong to the refraction of light. So just copy this part from here so we can proceed to the next part. Now, the third case that is related to the effect of refraction is the third case is about apparent shift in position of sun during sunrise and sunset. Now, sun appears to be actually rise before as it appears above the horizon. So, how actually it happens? This concept is similarly working on the atmospheric refraction. So, let's see from the diagram what actually happens here. This is our horizon. This is horizon. This is our atmosphere. This is the apparent position of sun. And this is what? This is the actual position of sun. Here, an observer is analyzing this phenomena. So this is how the apparent shift in the position of sun during sunrise and sunset appears here. Now you can see that this concept is actually based upon atmospheric refraction. This is based upon atmospheric refraction. Now, what will happen here during atmospheric refraction? You know that there are different layers in the atmosphere. Air is also present in the atmosphere. So we have the different densities at the different layers and the refractive index. Now what is refractive index? That we are going to discuss in our next lecture. The refractive index of the mediums differently occur here. So there is a different refractive index for different medium we have. So as we go high up on the altitude, we see that the density of the air keeps on rising and the air pressure is going to be decreased. So what will happen due to this atmospheric refraction? You can get that there is a shift in the position of the actual and apparent by 0.5 degree. It means the sun will be shifted by 0.5 degree, and you can see just 2 minutes before the sunrise and sunset. So you can see that there is a difference of 4 minutes in actual sunrise, and you can see here the apparent sunrise. So the whole day will be going to be increased by the 4 minutes. So this is an observer observing the sun here. This is the actual position of the sun we have, but apparently it is seen here. So you can see that there is a shift of 0.5 degree. 0.5 degree shift is going to occur between the actual and the apparent position of the sun, and that's why you generally observe that before sunrise you just observe the sunrise just before 2 minutes, and later on the sunset you will observe just before the 2 minutes. So you will observe sunrise and sunset two minutes before actual sunrise and sunset. So if this case is happening, you can see that there will be the 4-minute difference in the total timing we have. So the day will get longer by 4 minutes. So this is due to the atmospheric refraction. We are getting the different position of the sun, and this is a very interesting phenomena we have. Now in the effects of refraction, let's move to the last phenomena we have, that is about the twinkling of the stars. This is again a very interesting phenomena you have seen in the atmosphere. So how it is occurring, let's discuss here, but just copy that part from here. So the next effect is about the twinkling of stars. So the fourth effect is all about twinkling of stars. Now this is a very amazing phenomena you have seen in a clear sky, that in the night we have seen the twinkling of the stars. Why it is occurring so? It is just occurring because of the term that is known as atmospheric refraction. Now what will happen in the atmosphere? You have seen that we have the different layers in the air. As we go above the sea level, you can see that the density of the air is going to be decreased. If density of the air going to be decreased, you can see that when a light is traveling from the heavenly bodies, it is going to bend away from the normal. Why? Because it is traveling from denser to rarer medium. So if it is changing its position time to time, and you can see that there is a temperature difference in the different layers of the atmosphere, so this may give rise to a convection currents. So if this is happening, so we can see that the air reaching to the eye of an observer is not same. We can see that the intensity of the light for different observer is different, and we will not get all the light rays of the same intensity. So that's why this phenomena is occurring, and this is known as the twinkling of stars. And again, we have the different refractive indexes of different layers in the different mediums. So the twinkling of the star is occurring due to that concept also. So I can say that we can see numerous stars twinkling in a clear sky. This is due to the atmospheric refraction. This is due to atmospheric refraction. Now this thing is occurring just due to a phenomena known as atmospheric refraction. We can say that as we go up, density of air decreases. So there will be a different densities at the different layers of the atmosphere. So different layers have different densities, and different temperature will give rise to a different convection current. And when light will travel, it will travel from heavenly bodies. As it is traveling from denser to rarer medium, it will bend away from the normal. So light from the heavenly bodies will bend away from normal. And if it is bending away from normal, different people and different intensity of the light will be observed by the observer through the atmosphere, and this will give rise to the twinkling of the stars. So this is the whole concept related to the twinkling of stars. So we have seen that what are the effects of refraction in our daily life. First example, we have seen about the pencil. When the pencil is immersed in water, it appears to be a shorter length. When you observe a tank from the top part, you can see that the water appears at a smaller heights. Thirdly, you have seen that there is an apparent shift in the position of sunrise and sunset by 2 minutes or by 0.5 degree. This is also due to the atmospheric refraction. And last phenomena, that is twinkling of stars, is completely based on the atmospheric refraction. So this is all about the effects of refraction. Now we are going to start our next half, that is known as the laws of refraction, and it is again a very important topic we have. So let's start with laws of refraction. So our second topic is about laws of refraction. So let's start with a new topic, that is about laws of refraction. In our previous lectures, we have discussed about the laws of reflection. We have generally two laws of reflection. So in the similar way, the laws of refraction are also two. The first law states that the incident ray, the normal ray and the refracted ray. In this case, we have to deal with refraction. So we are talking about the refracted ray. So all these are going to lie in the same plane. So first point is similar to that of the reflection. Second law states that the ratio of sin I and sin R will remain constant. It means the angle of incidence and angle of refraction angle will going to remain constant, and this constant must be equal to the refractive index of the medium, because in our previous lecture we have talked about the term refractive index. So what actually this refractive index is, let me tell you now. So the first law states that, firstly let's have a first law. The first law states that the incident ray, normal ray and refracted ray. We have the three rays, the incident ray, normal ray and the refracted ray at a point of incidence lie in the same plane. So all the three rays will be going to lie in the same plane, and this will be about the first law of refraction. Now what second law of refraction states? Let's deal with second law of refraction. The ratio of sin I and sin R will be constant. So the ratio of sin I and sin R will be constant. This is known as a second law of refraction, and it is known by a very important law that is known as Snell's law. This law is given after the name of the scientist, so it is known as Snell's law. So second law of refraction is also known as Snell's law. Now what this law states that the ratio of sin I and sin R will be constant, and that constant will be equal to mu, and this mu will be known as the refractive index of any medium. So this is the statement we have for the second law of refraction. The ratio of sin I and sin R will be equal to mu, and this mu will be equal to a constant that is known as the refractive index of medium. So mu will be equal to refractive index of medium. So if I am writing one mu 2, it means it is the refractive index of medium 2 with respect to medium 1. So what will be this? This is the refractive index of medium 2 with respect to 1. So this nu will be the refractive index and this will be written like this. So this is the refractive index of medium 2 with respect to 1, and this is again known as the Snell's law, and this is a constant term we have. Now this refractive index of different medium have different values. It means for air it has a different value and for water it has a different value. Now these two laws of refraction will be applicable to both the type of the mirror, whether it may be our plane mirror or it may be our spherical mirrors. So this law will be applicable to both the mirrors we have. So this is all about the laws of refraction we have seen. Now we will see that how different mediums will have different value of refractive index, and let's do a simple question that is belonging to our second law. So let's see what the table is describing here. This is the table which is showing that different refractive index is possessed by the different mediums we have. So it is a refractive index of some material in a medium. You can see that air is having a refractive index approximately equal to 1.003. It means for air it is considered as a 1. So for solving some numerical problems, you have to remember that the refractive index for the air will be 1. Now you can see that it is different for water, it is different for kerosene, and you can see that for some organic compounds like benzene it is having value 1.50. Now you can see that here for carbon disulfide, diamond, we are having different refractive indexes. It means this is a table which is showing that different medium is going to possess the different refractive index. For the sake of convenience and for solving numerical problems, just remember the refractive index for air, water and glass. So this will be the refractive mediums for all these. For air you have to put the value of refractive index that is equal to 1. So this is how the table showing the different mediums have different refractive index. Now just by applying the laws we have discussed now in the some numerical problems we are dealing here. So let's have some numericals. So the first numerical question in this sequence we have. This is the first question. Now see what first question is saying. If refractive index of medium 1 is 4/3. So I am writing here what actually given to us. So the given condition is refractive index of medium 1 is 4/3. So refractive index of medium 1, that is equal to mu1, and it is given as 4/3. Refractive index of medium 2 is 3/2. So I am just writing here refractive index of medium 2 and it is mu2 and it is having a value that is equal to 3/2. So this is the refractive index of medium 1 and this is the refractive index of medium 2. Now you have to find out the refractive index of medium 2 with respect to 1. Now you have to notice here that refractive index will be given by mu, and if I have to determine the refractive index of 2 with respect to 1, so I have to write 2 here and 1 here. So this will be refractive index of medium 2 with respect to 1, and it is given by the formula n2 upon n1. So this is the formula you have to apply for solving this simple numerical problem. Now n2 will be the mu2 you have. It means the refractive index of medium 2. You can also denote these by n2 and n1. Now what is the value of n2? You can see that it is 3/2. And what is the value of n1? You can see here it is 4/3. So 3/2 into 4/3 can be written as 4 and 3 here. So what I am getting here? I am getting here 9/8. So what is the refractive index of medium 2 with respect to 1? It came out to be 9/8. So we can write that 1 mu2 will be equal to 9/8 and 9/8 will be the answer for this problem. So you can see that how simply you can solve the numericals that is completely based upon the refractive index. But you have to learn this simple concept that refractive index of 2 with respect to 1 can be written like this. So just copy this solution from here so we can proceed to the next question we have. Now the next question in this sequence we have is the refractive index of water is 4/3. So what is given here? First write the given conditions. Refractive index of water is 4/3. Refractive index of water, that is mu W, is equal to 4/3. And for glass is 3/2. So refractive index of glass is equal to 3/2. Now what is the refractive index of water with respect to glass? So you have to determine refractive index of water with respect to glass. So water can be substituted here and glass can be written like this. So this is the thing you have to determine in this question. Now what we will do, we have to analyze the refractive index of water with respect to glass. So it can be written like this, and I can write here mu of W upon mu of G, because we have to write mu2 in the numerator side and mu1 in the denominator. So it can be written like this. So you have to learn only this simple concept to write and solve this numerical problem. Now what is the value of water here? The value of water here will be 4/3. And what will be the value for the glass? You can see that the value for glass will be 3/2. Now we can write it as 4/3 into 2/3, and it came out to be 8/9. So we can say that refractive index of water with respect to glass will be 8/9. So this is the answer of this question you have. So this is how the numerical problems that is related to refractive index with respect to one medium and with respect to 2 with respect to 1 you can solve in this manner. So just try to understand these simple problems because this can be asked in your exam. Now these are the two simple problems we have regarding the refractive index. Now we have to determine the refractive index in terms of speed of light, in terms of wavelength, and what will be the refractive index that is of medium 2 with respect to 1 we can discuss now. So just copy this part from here. Now let's discuss the refractive index in terms of wavelength, speed of light and relative refractive index. So now we have to discuss the refractive index in terms of these three cases. So the refractive index in terms of the speed of light, it is in terms of the wavelength, and it is in the term having the mediums which are having the different speeds. So we are going to deal with these topics one by one. So firstly we are discussing what will be the refractive index in terms of speed of light. So if you are given with the speed of light in vacuum and speed of light in air, so what will be the refractive index in the first case? So we have the first case, that is refractive index in terms of speed of light. So refractive index in terms of speed of light will be given by C upon V. So this is the formula for writing the refractive index of a medium. Now this mu will be the refractive index, C will be the speed of light, and V will be the speed of any medium we are taking. It means the medium is traveling with certain speed, that will be the speed of that medium. So we can write there C will be the speed of light and V will be the speed of that medium. So mu will be given by C by V. Now if you want to determine the refractive index and it is given that the speed of light in medium with respect to speed of light in vacuum, you can call this term as the absolute refractive index. So we are arriving at a new term, that what will be the absolute refractive index. So this absolute refractive index will be refractive index of particular medium with respect to vacuum. So if you want to determine the refractive index of a particular medium with respect to vacuum, we can call this term as the absolute refractive index. So this is a new term you can see here. Now this is the first case in terms of the speed of light. Now we want to determine the refractive index in terms of wavelength. Now if we are going to discuss it in the terms of the wavelength, we know that the frequency will remain same throughout the medium. So what will be the formula for refractive index in terms of wavelength? Let's see here. The second case we have refractive index in terms of wavelength. In case of wavelength, if frequency is same, we can write that mu will be equal to lambda of vacuum upon lambda medium, and this C will be equal to lambda nu V, and this will be equal to lambda nu, and this is the frequency that is having the same value. So mu came out to be lambda vacuum upon lambda medium. So this will be the formula of refractive index in terms of wavelength. Now this is the refractive index in terms of speed of light, this is the refractive index in terms of wavelength. Now we are left with the refractive index of medium second with respect to one, and if I am finding the refractive index of any medium with respect to another medium, we can call it as a relative refractive index. This is absolute refractive index, and the term I am saying now is relative refractive index. So the third will be relative refractive index. So third case will be refractive index in terms of mediums. So refractive index of medium 2 with respect to medium 1. How can I write the refractive index of medium with respect to 1? I can write simply here 2 and 1. This is refractive index of medium 2 with respect to 1. So simply we can write here, this can be written as N2 upon N1. And the refractive index of medium 2 with respect to 1 will be known as a relative refractive index. So now we came to a new term we have, that is known as relative refractive index. We have the two refractive indices, that is absolute and relative. So this term will be the relative refractive index we are talking about. Now if I am comparing the two mediums, suppose I have glass and water or something, we are assuming that air and glass. So I am assuming here water and glass. So if this is the refractive index of water, and this is the refractive index of glass, so how can you write the refractive index of one medium with respect to another? This will be your relative refractive index. Now if I want to determine the refractive index of glass with respect to water, I am writing here refractive index of glass with respect to water. So I have to write the glass here and water here, and it can be written as like this. This is the refractive index of glass with respect to water, and it is given by this formula, and this can be called as our relative refractive index. So I hope these two terms has been clear to you, that what is absolute refractive index and what is relative refractive index. So in our today's lecture, we have deal with a very important topic, that is refractive index and what are the effects of refraction in our day-to-day life. So I hope this topic has been clear to you. So this lecture is over here. Thank you so much and have a wonderful day.